Howdy, I'm Adhyantha Chandrasekaran, and this is our deep demo for this year, which is the hydrogen line radio telescope. The theory behind it is that in a neutral hydrogen atom, there's one proton and one electron, and when their magnetic spin flips once in about every 10 million years or so, they release a very tiny amount of energy that we can detect with this telescope. And the way this telescope is designed is that it has the exact dimensions, and inside there's a small copper tube that is also proportional to the 21 centimeter hydrogen line that we are trying to detect. And if you slowly move to the side of the telescope, you can see that the signals are collected over here and then funneled through to the waveguide, which is over here, and we collect the data from here and plug it in to the circuit, which I will come in a bit to. But how we measure the data is that we use a bunch of manual tools to measure the angle of elevation of the telescope and the angle that it is pointed at to the sky, the azimuth and the altitude. And all that data goes into this circuit, which is then a simple amplifier and a filter and connected to the UI that we have on our computer. And it takes a bunch of time to process all of the data, but essentially we have this simulation of the data, which, if you look closely, it has a central red line, and the peak shows the frequency of the neutral hydrogen that we detect at a certain angle that we point the sky at. So if it's to the right of the red line, then we can see that it is blue shifted, which means that part of the galaxy is essentially moving towards us. And when the peak is to the left of the red line, it means that the data is red shifted, which means that that part of the galaxy is moving away from us. So that's the simple explanation of how this radio telescope works. Thank you. And this is the newer version of what we're trying to build, which is purely made of aluminum sheet, and each of the sheets has been bolted down with the hinges and screws. And this is what we're trying to use as the waveguide, which is just a tin can. And we will definitely be seeing this in next year's physics festival. Thank you.